Hey everyone, and welcome to this first video in our series on properties of geometric figures in the 5.2 Mathematics Pathway course in New South Wales. This video is going to focus on parallel lines. Now, parallel lines happen all over the place. They can be man-made, so they can be in buildings, railway lines, they can be in nature. And they can also come around on clothing patterns, and they just appear all over the place. And having some special properties around them and knowing those properties can make problem solving in geometry a little bit easier. Now, some things around parallel lines. The first thing that you're going to have or that you need to know about is what's called a transversal line. That's this word. The transversal line. So the transversal line is a line that cuts across two other lines. So it could be two or more other lines. So across two or more other lines. So the transversal line is what creates the special angles that we're going to talk about in this next bit. So here we've got some parallel lines, we've got some special types of angles within them, and you can see that our parallel lines here have the arrows that are the symbol we use to indicate that they are parallel. And then we have our transversal line right here. So that's our transversal. And then the green lines there are the parallel lines. So this type of line is the corresponding. So they're called corresponding because they sit in the same spot. Okay, so they sit in the same spot. So you can see here it's just under the green over the blue, under the green over the blue. So they correspond to each other. Now, the thing to know about corresponding angles, these angles are equal to each other. So if one of those angles is 63 degrees, the other one will also be 63 degrees. Our next set of angles here, well, these are alternate angles. So we can see our little transversal line here, and that those angles go on either side of that transversal line. So they alternate the sides on the transversal. Kind of like players playing tug of war. They're alternating sides of like a rope or something. These angles are also equal. So these angles are also equal. Now, our third type of special angle that we find in parallel lines, these are the co-interior angles. So here we have our transversal line, and you can see that we have this line here, A, and we have this line here, B. So we have line A and we have line, or angle A and angle B. Sorry, angle A and angle B. These guys have to add up to 180 degrees. So they are supplementary. Whoops. These angles are supplementary. So that means they add to 180 degrees, or they sum to 180 degrees. Some extra bits and pieces around angle properties. We do have some other types of angles that we need to know about. First, we have the vertically opposite angles. So that's C and A. So C and A there, they're vertically opposite. and vertically opposite angles are equal. Now we do have two other types of angles there. You can see D and E, they're alternating, so they're going to be equal. But the other thing is, they sit there on that line, sits on that line, they actually form angles on a straight line. And those types of angles are also equal. Well, they're not equal actually. They're angles on a straight line, they're supplementary. My bad. Looking at some different angles. So remembering that supplementary means they sum to 180. Let's check out some examples. Here's our first example. Find the value of all the pronumerals in the diagram. Write down the reason for each case. So let's look at A. A degrees, well, that will equal 180 minus 150 because these guys are supplementary. Which means that A equals 30 degrees. B degrees also equals 30 degrees. Okay, because they're alternate angles. Okay, so B and A are alternating, so they have to be that way. C will be that 180 minus 30, because those guys are supplementary. And for D, you can actually have a couple of different options. You can go the route of supplementary with A, or you can go there 150 degrees because they're vertically opposite. Okay, so A is supplementary with 150 degrees. So these guys are supplementary and add to 180 degrees. This guy and this guy, where they're alternate, which means they are equal to each other. This guy and this guy, well, they're supplementary again, so they add to 180 degrees. And then we have our last one there. We have the D and the 150. Well, these guys are vertically opposite. Now, please remember when we say vertically opposite, we don't mean they need to be standing upright. They just need to be directly opposite to each other, not next to each other. Okay? That's all that is going to mean. Alright, last examples here. We need to decide with reasons whether these pairs of lines are parallel or not. So here's our first one. We have two angles. We have one that is 120. We have one on the other side that is also 120. So these guys are alternate angles. alternate angles. These guys must be equal. Therefore, we do have parallel lines. We do have parallel lines. On the other one, well, let's see what's happening. These little fellas, these guys are co-interior angles. And you can almost see that they're co-interior because they kind of form a C shape for co-interior. So they are co-interior because they cooperate with each other on the interior of the angles. Now these guys need to sum to 180 degrees because they're supplementary, remember? Supplementary adds to 180 degrees. We have 120 plus 50, well that's 170. So for this one, we do not have parallel lines. We do not have parallel lines. That's it for this video. This should be fairly revision style for most people who are watching it. Just a refresher on how parallel lines work. Hopefully it has been informative and helpful, and good luck with all of your questions. See you in the next one.